Okay, hey guys, happy Tuesday. Welcome to TOC 520, where you've learned all of the types of factoring that you need to know. And remember, factoring is breaking up the standard form or that area section into tinier chunks that get multiplied. So, like if you have the number 6, the factors are like 2 times 3, right? So those would be your factors. And if you have x squared minus 4, your factors would be x plus 2 and x minus 2, right? So the fact that the parentheses are touching here is that same multiplication, right? So these are also factors. Okay, so you've learned how to do different types of factoring. Today we are learning how to keep factoring. So factoring completely until an expression cannot be broken up anymore. All right, so the warm-up asked you, hey, what's the difference between factors and roots? A lot of people confuse them and think that they're the same thing because they're so similar. But factors are really just another way to write a quadratic expression or equation. So a way to write a quadratic function. Okay, and the roots are actually when you solve for x. Okay, and so that's when you graph it, and let's say your quadratic looks like that. All right, so your x values, where it hits the x-axis, those would be your roots. Okay, so for example, if I had a quadratic function that was like x plus 2 times x plus 3, this is just a quadratic. I could even put y equals, put that in my graphing calculator and graph it. Whereas a root is actually changing that y into a 0 and solving for the x values. All right, so if I were to solve for this first parentheses, I'd have x plus 2 equals 0, and then you would subtract 2 on both sides and get x equals negative 2. All right, so the factor is x plus 2, and the root is negative 2, where x is negative 2. So they're very similar, but they are not the same thing. Okay, so this is what you'd put in your calculator, and the roots are what you would see in your graph, okay, at the x-intercept. All right, and let me just do the other one since I have it. So your other factor is x plus 3, right? That's inside the parentheses. And so if I set that equal to 0, x plus 3 equals 0, all right, then you'd subtract 3 on both sides, and your other root should be x equals negative 3. Okay, so your two factors are x plus 2 and x plus 3, right? They're what's being multiplied together to give you that quadratic function. And your roots are x equals negative 2 and x equals negative 3. All right, so you should have read through the examples on TOC 520. I gave you examples of each of the type of factorings that we've done. And again, what they all have in common is they can take a standard form equation or expression, and you can rewrite that into different pieces, right? And usually those pieces are either in front of a parentheses or inside of a parentheses. And you can just break it into little pieces that can multiply together, okay? So I hope that you look at those examples. We had GCF, grouping, trinomial factoring, and then there's special kinds of factoring that we call difference of squares and perfect square trinomials. Okay, so please look at those if you haven't. And then read the steps on factoring completely. Now, we normally say find the greatest common factor first if you can, if there is one. That's not every single time the case, right? There are different ways you can do that, but we are always going to do GCF first, just so we can kind of get into that pattern, right? And it's usually the best option. Like 90% of the time, it's the best option. Okay, and so factoring completely, we look for that GCF first, and then we look at each little piece and see if we can factor that piece further. Okay, so let's get started. In number 7 on your worksheet, again, I'm going to look for the greatest common factor first. So let me just put GCF. So between 8, 4, and 24, the biggest number that can divide into all of those is going to be 4, right? There's no other number bigger than 4 that would actually divide evenly into 4, right? And 8 and 24. All right. So now I look at the variables. Here I've got 4 x's, 1, 2, 3, 4. Let me put it over here. Here I've got 3 x's, 1, 2, 3. And here I've got 2 x's, 1, 2. So my GCF would only be 2 because I can circle 2 in every single term, right? I can't circle 3. If I had tried to circle 3, I could circle 3 here, but there's not 3 x's here to give, so I can't circle 3. I can only circle 2 because I can circle that 2 in every single term. All right, so I just 1, 2, 3, 4, and this one is 1, 2, 3, right? So I can circle 2 of them, right? So my GCF is going to be 4x squared. And remember, GCF, that F stands for factor. So this is one of my pieces, one of my factors, 4x squared. And in fact, if I wanted to do area model, I could put 4x squared as one of my lengths on the outside. All right, so now let's see what's left in the parentheses. And I'm going to do that distributive property to help me. So 4 times 2 would give me this 8. So 4 times 2 is 8. Okay. Now x squared times x squared. Remember, I add those exponents. So x squared times x squared. I add 2 plus 2 is 4. That gives me x to the 4th. Okay. Now minus 4x squared times, 4 times 1 would give me 4. And x squared, I need one more x. All right, and let me just rewrite that because if it's a 1, I just like making that invisible. Okay. And now let's see. 4 times 6. So I put minus 6. X squared, all I need is an x squared, so that's already there. Okay, cool. So I've factored using my GCF, my greatest common factor. All right, and if I were to do this box here, I would put 2x squared minus x minus 6. right? And so that would give me 8x to the fourth minus 4x to the third minus 24x squared. Oops, that went a little bit outside the box. Okay, so that's my first type of factoring. Factoring completely asks me to look at all of my factors and ask, can I factor that again? All right, so I'm going to erase what I don't need. I'm going to kind of erase all these dots I have. I'm going to erase down here. Okay. All right, so now one of my factors is 4x squared. Now, because that's outside of the parentheses, right? It's just, that's fully factored. I can't factor that anymore. The other factor is this trinomial, 2x squared minus x minus 6. All right. So I'm not quite sure what the factors are of that. Can I factor that more? So for that, I'm actually going to do an area model to help me figure it out. Okay, so it's a trinomial, so I'm pretty sure I'm going to set it up where I've got 1, 2, 3, 4 boxes. Okay, and remember that the first term, which is 2x squared, goes in my first box. And the last term, which is a negative 6, goes in my last box. Now, these two diagonal boxes, they need to combine. What do you think? They need to combine to give me a negative 1x. All right, that invisible 1 is there. So they need to combine to give me that negative 1x. Or just negative x. All right. So let's play around. All right. Let me use green for this. So for 2x squared, I know I need x times x to give me x squared. And the only factors of 2, remember it's a prime number, are 2 and 1. So let me make that 1 invisible, right? Okay, so 2x times x is 2x squared. And those are the only factors I can use there, right? So now for this 6, notice that it is a negative. The only way to get a negative, if you're multiplying, is doing a positive times a negative. All right, so I know one has got to be a positive, one has got to be a negative. Maybe I need to switch them around. We'll see. We'll see what happens. Okay, so the factors of 6 are 1 times 6 and 2 times 3. So let's try 1 times 6. 1 and 6. So negative 6 times 1 is negative 6. Great. And let's try here. So x times 1 is 1x. And negative 6 times 2 is negative 12. So negative 12x plus 1x, oh, that gives me negative 11x. So that's not going to be it. All right. Let me try it the other way. Let me try 1 over here and 6 over here. Okay. So here I've got x times 6 is 6x. And here I've got negative 1 times 2 is negative 2x. So let me see. Negative 2x plus 6x. No, that would give me 4x. Negative 2 plus 6 is 4. So still not giving me this negative x that I need. All right, so let's see. All right, so let's try, oops, I got my eraser there instead of my writer. All right, let's try this 2 times 3. All right, so let's put 2 here, 3 here. Okay, so now negative 3 times 2 is negative 6x. x times 2 is a positive 2x. So let's see. Negative 6x plus 2x is negative 4x. I'm still not there. All right, so let me use my eraser. And remember, this is a process, right? Sometimes it takes us more than our first try to figure out what the answer is. And that's fine. That's actually part of the math here. All right, so let me put my positive and my negative. All right, so wait, what did I do there? So I think I put the 3, so I'm trying to switch the spots. Hopefully I don't do this the same again. Okay. So let's see. 3 times x is 3x, and negative 2 times a positive 2 is a negative 4x. Okay. So negative 4x plus 3x gives me negative 1x. Excellent. Ding, 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 ding. Okay, so now I've got my factors. Remember, those are the outside lengths. Okay, these guys. So I am going to come back here. And again, remember, this 4x squared, that's as far as I can take that factor. So 4x squared. Now, this trinomial, that can be factored more. I just proved it with my area method. So I can have one factor is x minus 2, right? I got that from right here. That's one factor. So x minus 2 times, what do you think the other factor is before I write it in? Okay, so 2x plus 3. Okay, so it's important to note that this, and this, all three lines are equal to each other. If you put all of them in your calculator to graph, they should be identical. All we have done is taken this first standard form expression, and we have not only factored it once, right? So here it's factored, but in the third line, because I've got 1, 2, 3 factors, here it is factored. I might have to erase more. Completely. Okay, so the first one, the second line here, like where I'm making this big mess, right? That is factored, but it's not factored completely until every single factor has been factored again. Okay? All right, so let's look at number 8. And let me just erase this. Okay, I don't think that this one will take as much room. All right, so we're over here. I see a difference. I see a subtraction. And I actually see a perfect squared term here and a perfect squared term here. So this is a difference of two squares problem. All right, now wait a minute. Didn't the notes tell me to do my greatest common factor first? It sure did. This is one of the ones that it will be okay either way, but I'm going to always do GCF first. And please do the same, okay? Until you get like a lot more comfortable with this. So my greatest common factor between 64 and 4 is 4. That's the biggest number that goes into 64 evenly, and 4. It's got to go into both. Now, I've got x squared and y squared here. Those are not the same variable. I don't care that they have the same exponent. It's not the same variable. So my only GCF here is 4. All right, now let's use that distributive property. So 4 times 16 gives me 64. And then I don't have any x's in my GCF, so they've all got to go inside here. So 4 times 16 gives me 64, and then the x squared goes inside. All right. Now 4 times 1 gives me 4, and then I've got y squared. And again, you know I like to erase that invisible one, make it invisible. Oops. All right. Okay. Now, if you notice, this is still a perfect square. This is still a perfect square term. And this is still a difference. So even though I've taken out the GCF, I can still do my difference of squares here. Now, remember, if you like doing the area method, and that is how you would like to do this, please do that here. It's the same thing where you make your box. First term goes in the first box, and the last term goes in the last box. And because there's no middle term, these x's should cancel out. Okay, now I'm going to use the shortcut, and you're more than welcome to do that too, but remember, you can use the area method here. All right, so the GCF, that's by itself outside of parentheses, that is factored completely there, right? Now, inside, I can do my dots, my difference of two squares. So, with difference of two squares, they should look identical except for the sign. So, 16, the reason it's a perfect square is because 4 times 4. So I've got 4x, so 4x times 4x gives me 16x squared, minus the square root of y squared is just y. And now the next one should look identical, except it has a plus sign. So the only difference in your factors when you're doing a difference of two squares is that sign. All right, so I have factored once, right? Here I factored once. So this is in factored form, but this is factored completely, and I'm not going to fit that in. All right, so the first line is standard form. The second line is factored, and the third line is factored again. So that's factored completely. Okay, so we've got some Regents review. I'm actually just going to do number 2 with you, just because I want to keep this under 25 minutes. All right, so when I look at this, there's no GCF. And I can tell it's a difference of two squares. So 9 is a perfect square term, 3 times 3. 100 is a perfect square term because 10 times 10. And x squared, again, x times x, perfect square term. So the square root of 9 is 3. Square root of x squared is x. And then remember, I'm going to have an identical parentheses over here, except for the sign. So square root of 100 is 10 times 10. So the b value here would match up with the tens. So my answer would be 2. All right. Okay, maybe we can do number 1 really, really quick, and I can still get it under 25 minutes. Okay, so the GCF here is x. They all have an x. And this guy here only's got one of them. So x times x squared gives me x to the third. X times 13x gives me negative 13x squared. And x times negative 30 gives me negative 30x. All right. And now, oh my gosh, I think I'm going to run out of time. Okay, so first term goes first box. Last term goes last box. And they already give me some options here, either 3 and 10 or 2 and 15. So I'm going to let you guys take it from there. All right, so just over 25 minutes. If you have any questions, comments, or concerns, take ownership of your learning, email me, phone a friend, use that Google. Lots of good YouTube videos out there, but really dig into this. It's such an important concept, and we're going to be having a test, probably not next week, but the very beginning of May, like that first week. All right, have a great day, and I will see you tomorrow.